Chemistry. This lesson is on mass spectroscopy, sometimes said spectrometry. Okay, so mass spectroscopy is a way of determining the mass of an isotope and the percentage of each isotope in a sample. It works on the principle that a lighter isotope can turn faster than a heavier isotope. So there you see a truck and a motorcycle turning a corner. If a truck and motorcycle turn a corner, the lighter motorcycle will turn quicker than the heavier truck. So lighter isotope atoms curve quicker than heavier ones. Okay, so mass spectroscopy is a way of determining the mass of an isotope. It works like this. The isotope atom is ionized so that it has a charge. An atom must have a charge in order to be moved by a magnet. A magnet on the left side of that apparatus pushes on the isotope and pushes it to the right through the tube. So that a magnetic field moves ionized isotope atoms through the tube. The isotope atom passes through a perpendicular magnet, that's the one you see there, that causes the isotope to curve. So this perpendicular magnet causes the isotopes to curve. How much the isotope atom curves depends on its mass. A heavier isotope will take longer to curve, and of course a lighter one will be able to curve quicker, like the motorcycle. So there you see, if the isotope hits the top of that detector on the top side, that's going to be a heavier isotope. And you can see the line on the graph over there at 100. That would be the atomic mass of that isotope. A lighter isotope would turn faster and hit the bottom of the detector, and there you see the line at 92. That would represent the lighter isotope. So question, without calculating, estimate the atomic mass and identify the element whose line spectrum is shown to the right. So if you look at that, you see three lines kind of to the left of center and two to the right of center, but the one of the two to the right of center, the one at 80, is much taller. So this is going to be kind of a weighted average. You're kind of estimating, where do you think that line would be? Well, a first guess is draw a line halfway between the bars furthest on the right and the left. There are three bars to the left. However, the bar at 80 is much taller than the others. So you could estimate that where you drew that line is pretty close to the average of those. This suggests that the atomic mass is about 79 and the element is selenium. You would go to your periodic table, look for an element with a mass close to 79, and selenium would be the closest. Okay. Identify the atomic mass and element of the graph shown below. So take a look at that. You see 5 different mass numbers of 5 different isotopes. The one at 70 looks like it's about at 20, maybe a little below. The one at 72 looks like it's a little below 30. The one at 73 looks like it's a little below 10. Then 74 is a little bit below 40. And then 76 looks kind of like 73, so a little bit below 10. So you would multiply those percentages. Remember, percentage you have to compute to a decimal number, and then you would multiply by each of those mass numbers on the bottom. So this is what you might have gotten. You have the 70 at 0.18. Okay, you might have guessed 0.19 or 0.2. 72 is 0.28. That looks about right. 73 is 0.08. Okay, a little bit below 10. And 76 is also 0.08. So this is called a weighted average. So you multiply those percentages times the mass numbers rather, and the atomic mass is 72.8 AMU. From the periodic table, the element with an atomic mass closest to this is germanium. So summary of mass spectroscopy and PES. Mass spectroscopy determines the mass of isotopes of an atom and the percentage of each isotope at each mass number. PES determines the ionization energy of an atom, so that's the difference between the two. All right, and that takes care of this lesson on mass spectroscopy.